Alright guys, so in the past we have talked about how to add, subtract, and multiply polynomials, but what we haven't talked about is how to divide them yet, and that's going to become really important when we're starting to figure out what the roots are of some of these polynomials. So, starting off, what we're going to be doing today is we're going to be using long division, which is something you probably did back in 3rd or 4th grade, to divide a polynomial by a binomial. So I'm only going to be dividing polynomials by polynomials that have two terms, right? Binomial down here, this is a binomial, never a trinomial, at least to start. All right, so before we do that, I just want to remind you guys of how long division works. This will be pretty quick, but you guys should be familiar, like in example A, with how to divide 362 by 3. Right, the first thing we're going to do is we're going to divide 3 by 3. 3 divided by 3 is 1. And then I'm going to do this 1 times 3 gives me 3. And now I need to subtract and bring down the 6. And now I'm going to try to figure out how many times does 6 or 3 go into 6. Or in other words, what is 6 divided by 3? That would be 2. Then I'll do 2 times 3. That would be 6. Then I subtract, bring down the 2. How many times does 3 go into 2? None. 0 times. It does not go into 2. So I'll put a 0 here. 0 times 3 is 0. 2 minus 0 is 2. And I could continue on, right? I could use decimal places if I wanted to. But what I see here is that I have a remainder of 2. So the way I'm going to write my remainder is that is going to be a 2/3. So this is kind of like a mixed number. It's 120 and 2/3 because that's the remainder. That's a very fast run through of polynomial or of regular long division, but we're going to have to be able to apply that to polynomials, so you should be familiar with how to do problems like that. If you're not, I would practice some of them right now, make up some division problems and try them and get good at doing the regular long division because we're about to do a polynomial. So when we divide polynomials, it's the same thing. We're going to do in B what we just did in A. We're going to take our dividend, which is x to the 3rd plus 6x squared plus 11x plus 6, and we're going to divide it by our divisor, x plus 4. Okay? We have a series of steps that we're going to run through here, and as we do the steps in the example over here, I'm going to list those steps over here so that we have them for the future. Step 1 is we're going to say, how many times does x go into x cubed? Just like over here when we said how many times does 3 go into 3 and it was 1 time, we're going to say how many times does x go into x cubed? And the answer is that if I do x cubed divided by x, I would get x squared. So the answer to that question, how many times does x go into x cubed? The answer is x squared times. That's how many times x goes into x cubed. All right? Then over in our example with numbers, we took that 1 and multiplied it by the 3. We're going to do the same thing here. We're going to take the x squared and multiply it by both of these two things, right? We're going to multiply it by x, and we're going to multiply it by x plus 4. And when I do x squared times x plus 4, I'm going to get x to the 3rd plus 4x squared. Okay? Then just like in my previous example when I used numbers, I took that product and subtracted it from the above number. So I'm going to do the same thing here. This is going to be subtraction that takes place. So I need to do x cubed plus 6x squared minus x cubed plus 4x squared. So when I do that, I'll notice that x cubed minus x cubed is 0. These will cancel. But when I do 6x squared minus 4x squared, that's going to leave me with just 2x squared. All right, so the subtraction is taken care of. In the example with numbers, we brought down our 6, which is the next term over, and we're going to do exactly the same thing here. We're going to bring down that 11x. So that's our next step. And now that we've done that, the next thing we need to do is just repeat. We're just going to repeat this process. So now, instead of how many times does x go into x cubed, I'm going to ask how many times does x go into 2x squared. Sorry, how many times does x go into 2x squared? Well, if I do 2x squared divided by x, I'll get 2x. So x goes into 2x squared 2x times. And then I'll do 2x times x. And then I'll do 2x times 4. And now I need to subtract. 2x squared minus 2x squared is 0. This will always happen. If you're doing it correctly, the first terms will cancel, but these probably will not. So 11x minus 8x is 3x. Now I have to bring down that 6. How many times does x go into 3x? The answer is 3 times. 3 times x is 3x. 3 times 4 is 12. And I subtract and get negative 6. All right, so when I'm done, just like how in the first example when we had numbers, we had a remainder, we have a remainder here. Notice that our remainder is whatever our remainder was divided by the divisor. We're going to do the same thing here, our remainder over the divisor. So that's going to be minus 6 over x plus 4. And that's your final answer. The quotient is x squared plus 2x plus 3 minus 6 over x plus 4. And I know that that seems like a lot right now, but we're going to practice this a bunch of times. We're not just going to throw this away after one example. All right, I'll do one more with you here. I'll do D with you, and then C, I'll have you guys try on your own before we get to class. Okay, so D. This one's just a little different, and I want to make a note because you'll notice that there are some terms missing. I have an x to the 4th, I have my x squared, and I have a constant, but I'm missing an x to the 3rd term, and I'm missing an x term. It's important to note that because when I write this out to do division, I need to hold the place of those missing terms with zeros. Otherwise, I'll be missing columns in my division. So I have to hold those places with zeros. If I were you guys, I would write that over here on the side. When terms are missing, make sure that you hold their places with zeros. And then the x plus 2, that's the same. All right, now we're just going to go through the same process. How many times does x go into x to the 4th? Well, x to the 4th over x, if I divided, would be x to the 3rd. So x goes into x to the 4th, x to the 3rd times. X to the 3rd times x is x to the 4th. X to the 3rd times 2 would be 2x to the 3rd. I subtract. Thankfully, these cancel. That means I'm doing something right. 0x cubed minus 2x cubed is negative 2x cubed. Bring down my negative 2x squared. Now, how many times does x go into 2x cubed? Well, negative 2x cubed over x, if I divided, would be negative 2x squared. So x goes into negative 2x cubed, negative 2x squared times. Negative 2x squared times x is negative 2x cubed. Negative 2x squared times 2 is negative 4x squared. Now I subtract. Negative 2x squared minus negative 4x squared. These cancel, but this is a keep, change, change, right? Negative 2 minus negative 4. So that's 2x squared. Bring down the 0. X goes into 2x squared, 2x times. You guys should be starting to see the pattern by now. 2x times x is 2x squared. 2x times 2 is 4x. I subtract. First terms cancel. This leaves me with 4x. Bring down the 1. And this is happening quickly, but you guys are watching it in a video, so I would hope that if you get stumped with a part of it, that you would pause it and take a look at what happened in that step. The last step here is a 1 minus negative 8, because these terms will cancel, and I'll be left with a 9. So 9 is my remainder, which means my final answer is x cubed minus 2x squared plus 2x minus 4 plus 9 over x plus 2. And that is my quotient. Remember, the quotient is the result of a division problem. So before you come in tomorrow, do C on your own. We'll talk about C before we get started on our independent practice, but we will get more practice with this.